Compositions of functions are when we place one function inside of another. So, for instance, if I have f of g of x, which could also be written as f of g of x, that literally means we're going to take the g of x function and put it into the f of x function. So, for instance, if I have f of g of x, and I'm going to rewrite it in this way, I'm going to replace g of x with what it's actually equal to. So g of x is x minus 1. So let's replace g of x with x minus 1. Now we have f of x minus 1. What does that tell me to do? Well, that tells me to put x minus 1 in the place of x in the f function. So I'm going to put x minus 1 in the place of x, and that would give me the square root of x minus 1. And so that is my composition. Look at another one of those, all right? We have g of f of x. I'm going to start on the inside with what is f of x? Well, it's the square root of x. So let's replace f of x with what it's equal to, the square root of x. Now I have g of the square root of x. That tells me to put square root of x in the place of x in the g function. So I'm going to put the square root of x in the place of x in the g function, and that would give me the square root of x minus 1. So the square root of x minus 1 is my composition. We can do compositions with values as well. So if we had f of g of 2, let's start with finding g of 2. So you can literally just put your finger over the f for a second and just focus on g of 2. So g of 2 tells me to put 2 in the place of x. So if I put 2 in for x, 2 minus 1 would just give me 1. So since g of 2 is equal to 1, we can replace it with what it's equal to. Now I have f of 1. So f of 1 tells me to put 1 in the place of x in the f function. So if I put 1 in for x, I'll get the square root of 1, or 1, and so that would be my composition. All right, how about f of g of 0? All right, let's start with g of 0. So we're going to put 0 in for x in the g function. So if I put a 0 right there, that's going to give me negative 1. Now I have f of negative 1. So if I put negative 1 in the place of x in the f function, I'll get the square root of negative 1, which is I. So you can see we're going to have some domain restrictions with compositions. So let's look at another one of these, and then we'll look at the domain associated with it. All right, so for this next one, f of x is 1 over x, g of x is x plus 1, and they asked me to find f of g of x. So let's start on the inside, and let's replace g of x with what it's equal to, which was x plus 1. Now we have f of x plus 1. So we're going to put x plus 1 in the place of x in the f function. That'll be 1 over x plus 1. And so that's my composition, 1 over x plus 1. Now when you want to find the domain of a composition, you're going to find the domain of the inside function, the one you plugged in, and intersect it with the domain of the final answer. So the composition can only exist where both of these things exist. So let's say you have f of g of x, as we do in our current example. The inside function is g of x, so I'd find the domain of g of x, and I'd find the domain of my final answer of the composition, f of g of x, and I would see where those overlap, where they both exist. All right, so if we look for the domain of g of x, your domain is going to be all real numbers unless you have 0 in the denominator or a negative under an even indexed radical like a square root or a fourth root. So I don't have a fraction or a radical here, so that domain is going to be all real numbers. Then I'm going to look for the domain of my final answer. So looking at this, my denominator cannot be equal to 0. So -1 would give me 0 in the denominator, so I'll have to exclude it. That's the only thing I have to exclude though, so all real numbers except for -1. So if this one exists everywhere and this one exists everywhere except for -1, then they're going to intersect everywhere except for -1. And so the domain of the composition would be all real numbers except for -1. We've seen how to do compositions with equations, but we also can do compositions from tables and from graphs. So for instance, if we have f of g of 3, again, you can put your finger over the f and just focus on the g of 3. So for g of 3, I'm going to put 3 in the place of x, and then you'll notice that I have an f of x column and a g of x column. So if I put 3 in for x and I come to the g of x column, that would be g of 3. So g of 3 is 2. So if g of 3 equals 2, I can replace g of 3 with 2. Now I have f of 2. So that tells me to plug 2 in for x. So I'll go back to my x column, and this time I'll put in 2, and I'll be looking at the f of x. So if x is equal to 2, then f of x is equal to 8. So I'll replace f of 2 with 8, and that will be my composition. Look at another one of those. Again, we start on the inside, so ignore the g, put your finger over it for a second, and just look at f of 3. So I'm going to go back to the table and look at when x is equal to 3, and I'm going to look in the f of x column. So f of 3 would be 3. So replace f of 3 with 3, and now we have g of 3. So I'm going to go back to the table, and this time x is equal to 3, and I'm looking in the g column. So g of 3 would be 2. All right, if we look at a graph, we have f of g of 1. So again, ignore the f out here. Just focus on the inside, g of 1. What does g of 1 tell me to do? Well, it tells me to put 1 in the place of x and find y. So if I come over here and I put 1 in the place of x and I find y, you'll notice that that ordered pair is 1, 3. So when x is equal to 1, y is equal to 3, so g of 1 is 3. Now I have f of 3. So that says put 3 in the place of x and see what y is. So we'll put 3 in the place of x. This is the f function, right? So we'll put 3 in the place of x, and that gives us 6. So f of 3 would be equal to 6. You also can do a decomposition of functions. It's kind of like playing Jeopardy. It's like when they give you the answer and they ask you to go back to the original question. They ask you to give the original pieces that made that composition. The easiest thing to look for is something that has been put into the function. And usually you can recognize that because it might be in parentheses, or it might be in a denominator, or under a radical, or in an absolute value. So look for some kind of quantity that looks like it's been inserted into the function. So to me, this x minus 2, because it was in parentheses, stood out, that maybe it had been inserted in the function. And since g of x is what got inserted, I'm going to try g of x is equal to x minus 2. To find my other function, I replace this with x. So I'm going to replace x minus 2 with x. That would leave me 1 over x squared. That is my other function. So again, to find this other, I found my first one. To find this other function, I'm just going to take whatever this was x minus 2, I'll replace that whole x minus 2 right there with x, and that would be 1 over x squared for my other function. If you put those two back together again, sure enough, it would give you that composition. Maybe you looked at the whole denominator as the piece that was inserted into the function. Okay, well, if you did that, if you said that g of x was x minus 2 squared, then to find your other function, remember that you replace the first function with x. So I would replace x minus 2 squared with x, and that would leave me with 1 over x for the other function. And again, that composition works as well.